those. Okay, so when we first learned about polynomials, we classified them. We said a monomial has what? What is a monomial? It just has one term. One term. Okay. A binomial has two terms. Yeah. And the terms are joined by plus or minus. Ladies, shh, quiet, or I'm going to make you move. Terms are joined by plus or minus signs. Terms are joined by plus or minus. A trinomial has three terms. A polynomial has four or more terms. A constant is just a number. Okay. It can still be a monomial. A number can be a monomial, right? All by itself. But a constant is a number that has no variable, which means it is degree 0. A constant is degree 0. Why is that? Well, I'm going to just show you really fast, just because I like to know why. So y is a constant degree 0. This is just a, I wonder. Well, let's say that I said my constant was 4. Well, if it's degree 0, that's the same thing as saying 4x to the power of 0. Because the degree is based off of the exponent on the variable. A degree is based off of the exponent on the variable. And what is x to the power of 0? No. If it was 0, then 4 times 0 is 0, right? It's 1. Any number to the power of 0 is 1. So this is the same thing as saying 4 times 1, which is in fact 4. That's why it's degree 0. Okay? That's important to know. So we're going to name, we're going to classify these by using monomial, binomial, trinomial, polynomial, but we're also going to say what degree they are. So for number 1, how many terms does this have? Has 2 terms. 1, 2. 2 terms is a binomial. What degree is this? Meaning what exponent is attached to the variable term? 1. So if something is degree 1, we say that it is linear. Do you guys remember that? Degree 1 is linear. Okay. How many terms does the second one have? It also has 2 terms, so it is also a binomial. However, what is the degree? It's degree 2, and degree 2 is called a quadratic. And if you forget that, think about what x squared is. What do we call x squared functions or x squared equations? We call them quadratic equations. How many terms are in number 3? 4 terms. So 4 or more, it's called a polynomial. And what degree is it? So we say the degree is based off of the largest exponent. So it's, degree 3, which is called a cubic. Okay, it's called a cubic. Number 4, well, it's a monomial. It's a monomial because it's one term. We call it a constant. We call it a constant because it is degree what? Degree 0. Yes. Number 5, it's a trinomial. What degree is it? It's a degree 2, which makes it a quadratic. Yes. And the last one, number 6, and it is degree 3, which is cubic. So we do remember naming, classifying polynomials by their degree and the number of terms. Okay, some are shaking their head, yeah. Okay, now we're going to write stuff in standard form. What does it mean to put a polynomial in standard form? Yes, yeah, so we need to go from the largest to the smallest in terms of degree, right? Largest to the smallest in terms of degree. So that's what standard form is. We go from the largest degree to the smallest degree. So for the first one, I'm going to just put the degree over each term. So x cubed is degree 3, x squared is degree 2. So is that written in order from largest to smallest degrees? Yeah, I saw Gavin shaking his head yes before he even started talking. So yeah, that's good. What about this next one? This is degree 0, degree 1, 2, 3. So fix it for me, Brody. Tell me how to fix it. Largest degree has to come first. Okay. Perfect. Awesome. Okay. I'm going to pause the screen and I want you guys to do C and D. I'm going to pause the screen and I want you to do C and D. Does anyone want to share their answer for letter C? To the fourth. Mm-hmm. Perfect. Perfect. 17x to the fourth plus 2x squared minus 3x. And letter D, Alexis. Absolutely perfect. 2x squared plus 3x minus 1. Yeah, no, perfect. Perfect. Okay. All right. Example number 8 says given 2x cubed minus 5x squared minus 2x plus 12. My first question is, before you start answering about leading terms and all of that good stuff and number of terms, and I want to ask you, is this in standard form? Yes, it is. Okay. So when you see something like this, before you start answering how many terms there are, what's the leading coefficient, you have to make sure it's in standard form, because otherwise you could have the leading coefficient wrong. Okay. And you need to make sure that there aren't any like terms, like anything that you can simplify. So this is in standard form. Dakota, how many terms are there? Yeah, 4 terms. Absolutely. What is the coefficient on the third term? What is the number? So coefficient, remember, is the number that's hooked to the variable. What is it? What is the coefficient? What is that number, Dakota? Nope. Third term. -2. Yeah. The coefficient is -2. What is the constant in this example, in this polynomial? It's +12. Yeah. Perfect. So 4 terms. Coefficient, remember, is the number on the variable. The coefficient of the third term is -2, and the constant is 12. So I'm only going to do some of these. So we're going to add polynomials. Remember that you can only combine things that are alike, meaning they have the same exponent to the same power. Same exponent, same power. Or same, I should say, dang it, same variable. That's what I want to say. Same variable, same power. Okay. So when we did these, my brain likes to work like when we started adding 3 and 4 digit numbers, I just stack them up. So the first one, 19x squared plus 12x plus 12. And right below that, I'm going to add 7x squared, and I'm going to line it up right below the 19x squared. I'm going to add 10x squared, or sorry, 10x, and I'm going to add 13. And I just put a big old bar underneath it and add each grouping.
26x squared plus 22 plus 25.
Awesome. Plus 22x plus 25. Very nice, sir. Perfect. That's absolutely perfect. You guys feel okay with that? Yeah. Again, this should all be review. Okay. All be review. Let's see. Who feels like they could do number 13 on the board? Okay. Kane, you have number 13. Who feels like they could do number 14 on the board? Yep. Go ahead, Logan. And who feels like they could do number 15 on the board? Dakota. Perfect. What's your calculator? Who has calculator number 3? No. You're not reminding us of number 3, are you?
You take my calculator?
Okay. What calculator do you have?
I thought it was 3. I think it's 2.
That's right. You're right.
That's probably me.
I just couldn't read that last number. Can you just write it a little bit bigger? Just all of it. Write it all a little bit bigger. I'm sorry. I have old lady eyes. Perfect. Okay, Kane, read off your answer. Yes, negative 15x squared minus 21x minus 11. Logan, you had x squared plus 32x plus 18. Okay, x squared plus 32x plus 18. And Dakota.
9x plus 14x. The fifth minus 15x plus 14.
Yeah, Dakota, the only feedback that I want to give you is look at your 4x to the 5th. It's negative. You have a negative 4 and a positive 10, which gives you what? 10 minus 4 is what?
6.
So make that 14 a positive 6. So plus 6x to the 5th. Perfect. So 9x to the 6th plus 6x to the 5th minus 15x to the 4th plus 14. Perfect, gentlemen. Not yet. Oh, yeah. Go ahead. Erase it. Thank you, sir. So those are the answers up there. I'm going to give you guys a minute or less to write those down because our notes are posted. Our notes are posted.
Does it matter if it's 1x or 2x?
No, 1x and x squared are the same thing. If there's, right? You don't need a 1. It's like saying that you have, I don't know, A and 1A. I don't know. We just typically don't put a number in front of just if it's x all by itself. That's the same thing as it's understood that it's 1. Just like we don't write something to a power of 1. It's just understood it's to the power of 1. Okay. So we have those written down. We're good. Need a minute. All right. I am not going to do 16 or 17. Again, I scanned and posted this. I think you guys will be fine without it. But we are going to do number 18, 19, and 20. Okay, is everybody good with writing those down? We feel okay about those? Okay, so I'm not going to do 16 or 17, but I am going to jump to 18, 19, and 20. So tell me, what is the biggest mistake that we make when we subtract polynomials? Any ideas? Say again? No, actually, no. The negative. Yeah. The negative is outside of a parenthesis. You have a negative outside of a parenthesis. What does that mean you have to do? What do those arrows mean? Yeah, that means you need to distribute the negative. You have to distribute the negative. I would say that that is probably the most common mistake. So I always rewrite these every single time. So I really have 6x plus 14. And I'm going to take this negative that's outside my parenthesis and turn that into a negative 9x and a negative 5. And now I'm just going to combine like terms. Okay. So a positive 14 and a negative 5 give me a positive 9. But a positive 6 and x and a negative 9x give me a negative 3x. Okay. If you don't distribute that negative, you're likely to write negative 3x plus 19, and that would be wrong. So again, I'm going to distribute the negative for number 19. So I have 14x squared plus 13x plus 12. And I'm going to distribute this negative 7 to each term in that bottom parenthesis. Negative 7x squared, negative 20x, negative 4. And then I'm going to combine like terms. Positive 12, negative 4 gives me positive 8. Positive 13x, negative 20x gives me a negative 7x. And a positive 14x squared and a negative 7x squared give me a positive 7x squared. So your final answer, 7x squared minus 7x plus 8. Okay. Flip over to the next page. And you guys are going to do 21 and 22 all by yourselves. You're going to do 21 and 22 all by yourselves. So here's what I want you to do. Rewrite the first polynomial and then distribute that negative through the second polynomial. But be aware, remember that a negative multiplied by a negative is a, thank you. A negative times a negative is a positive. So you guys are doing 21 and 22. Jacob, you got it, bud? Flip, flip. So you guys are doing 21 and 22. I'm going to freeze the screen and write those down for our viewers at home.
I heard you were recording it.
Yeah. Okay, who wants to share their answer with number 21? Who wants to go put their answer up there? Aiden T, you want to do that? You want to put your answer up there for number 21? I'll check it with you if you want before you go up there. You may look at it. Who's got 22? Kate, 22. A negative times a negative is a positive. So this is going to be plus. And a negative times a negative is a positive. So positive 18 and negative 14 give me what? Give me what? Negative and a positive give me 4. It's like saying 18 minus 14. So this is 23x squared plus 12x plus 4. Okay. Kate, you're going to have to write bigger than, yeah, because I got old lady eyes. We cannot see that. Good job, Aiden. Very nice, sir. Perfect. Perfect, ma'am. Perfect. So number 21, Aiden got 23x squared plus 12x plus 4. Number 22, Kate got negative 33x squared minus 3. Very nice. Very nice. Are we good with those? Please. Okay. So number 23. Number 23. When you multiply a monomial, turn around, please, and thank you. When you have a monomial outside of a parenthesis and it's just getting multiplied through by another monomial. So 2 terms getting multiplied together. Remember that you're going to take the constants and multiply them together. So you're going to figure out what 2 times 4 is. And then with the variables, when you have the same base and you're multiplying powers, what is the rule for the exponents? You add them. Good job. So 2 times 4 is 8, and 1 plus 2 is 3. So your final answer is 8x cubed. Now, I feel like we have done this enough times that you don't have to show, that step. I know that you guys mostly do that in your brain. Let's see. 17 times 2 is 34, and 2 plus 5 is 7. Negative 3 times 4 is negative 12, and 3 plus 2 is to the 5th. Negative 12 times negative 2 is positive 24, and 2 plus 1 is x cubed. Yes. Okay. And then we went on to take a monomial times a binomial, which is just what we've been doing since you guys learned how to distribute. You just take the number on the outside and you multiply it by each term on the inside. So those first 3, you guys should be like totally golden with, because there are no variable terms out there. So let's see. Josue, tell me what you get for 27. Steven, tell me what you get for 28. And Rylan, tell me what you get for 29. Ready, go. Just tell me. Say it out loud. Perfect. 4x plus 8. Thank you. Steven. Squared or to the power of 2. Either or, yeah. Perfect. Rylan, you got a big one there. You got it? Perfect. So the only time it gets weird is when you have a variable on the outside being multiplied by a variable on the inside. Same as when you did that up top, though. So 4x times 1 is 4x, and 4x times a negative x is negative 4. Add the exponents. Yeah, x squared. Good job. So who wants to do number 30? Someone who hasn't gone yet. Someone who hasn't gone. Alexis, you have number 30. Who's doing 31? Yep, do it on the board, please and thank you. Who's doing 31? Brody, I can see you're itching to get up there. Come on, Brody. Do 31. You've already done one, Kate. Corbin, you got 31 or 32? Which one do you want? Because Brody will take the other one. Okay. Shh. Huh? Okay. So, Brody, will you do 32? And Corbin's going to do 31. Ready, go. Yep, just walk on up there. Brody, you can call. Do you want to phone a friend? Shh. Pull Trevor up there with you. Go, Trevor. You guys both have 32. Shh. Go, go, go. Go on up there, Corbin. You have number 31. Corbin, you can phone a friend if you want. But I think you got it. I want you guys to try these at home. You should be able to do this. Don't wait for them to do it. Do it yourself. See if you get it right. Don't wait for the guys up front to do it. You're good. Yep, you're good. Perfect. What's 3 times 12? So negative 36. That last one is negative 36 minus 36x. So put it right next to the 6x squared. Yep. Yep. Okay. My only feedback is, what is a positive 3 times a negative 1? So put a negative out front. There you go. Perfect, gentlemen. Outstanding. Very good. Thank you guys for volunteering or being voluntold. Awesome. Dakota, will you jump up there and do an erase real fast? So number 30, negative x cubed minus 5x squared. Number 31, 12x to the 5th minus 15x cubed plus 30x squared. And 32, negative 3x cubed plus 6x squared minus 36x. Minus 36x. Number 33, 34, and 35, we are just dividing by a number, right? We're just dividing by a number. So it's no different than when you guys learned how to look for a GCF, right? You're taking a GCF out of everything. What is negative 15 divided by 5? It's negative 3. The x comes along for the ride. What is 10 divided by 5? Positive 2. What is 6x squared divided by 2? And what is 10 divided by 2? What is a negative 18 divided by a negative 3? A positive 6x squared. Very nice. And a positive 21x divided by a negative 3? A negative 7x. Yes. Okay. It only gets weird when you have variable terms. So I'm not going to do 36. You guys can do that one on your own. What is the rule when you have something like 20x to the 4th divided by 5x squared? Say again. It's not divide the exponents by each other. It's you subtract. Yeah. So 20 divided by 5 is 4. And you have you have 4 powers minus 2 powers is 2 powers. 15 divided by 5 is 3. And you have 2 powers divided by 2 powers. 2 powers divided by 2 powers is what? Or 2 minus 2 is what? Is 0 powers. So do I write, where did that come from? Do I write x to the 0 power? No, because what is x to the 0 power? Nah! What is anything to the 0 power? 1. So it's just like saying 3 times 1, which is just 3. You guys let me trick you on that one. So remember, when we started doing this and we were making lots of mistakes, we kind of said, okay, I have 4 powers up here and only 1 power down here. Which one has more powers, the top or the bottom? The top. So when I divide, when I subtract, I'm going to end up with more on the top, right? 4 minus 1 is 3, x cubed. What's the next one? Plus 3x what? And the last one? Plus 7, yeah. Okay. And then the last thing we did was FOIL. Nobody in period 1 could tell me what FOIL stood for. I wanted to jump out the window, but I didn't because my booty is too big. So, shh, I know that everybody knows how to do it, but what's the purpose of saying FOIL if you don't even know what the heck that means? Like, then why don't we just say double distribute? I mean, yeah, they do. You're exactly 100% correct. What does FOIL stand for? F stands for first. Take the first term in the first parenthesis times the first term in the second parenthesis. X times X is, it's X squared, right? Because when the base is the same, we add the powers, we add the exponents. Let's see. O stands for outside. We take the outside term of the first parenthesis and the outside term of the second parenthesis. What is X times 4? Yeah, 4x. Yes, I heard what you said. I think I heard what you said. Yes, I'm going to do that next. Okay. And then inside, that's what we're doing next. Inside, let's see. That means I take the inside term of the first parenthesis times the inside term of the next one. -3 times x is awesome. And then I'm going to take the L, stands for last. I take the last term of the first parenthesis times the last term of the second parenthesis. That gives me -3 times 4, which is -12. And then I just combine these. My final answer is x squared. This equals plus x minus 12. Now, you are the first person to say that, and I tried showing everybody that this morning, and they forgot about it. We talked about doing this like this. Two x, and actually I put it over here. I was just going to run into the problem, but yeah, we used a box, and that really helps when we have like a 2-digit number times a 3-digit number. 2x times 2x is 4x squared. 2x times 4 is 8x. 3 times 2x is 6x, and 3 times 4 is 12. And we said we could probably almost always do what with that diagonal? Yeah, combine those. So I end up with, you're fine, because they're both positive, so we are going to add them. So we end up with 4x squared plus 14x plus 12. Okay, so pick any other problem. I don't care which one, and just do it. I'm going to freeze the screen, and then you can check your answers in 2 hot seconds. I'm almost done. 6 and 8 is x plus 12. We ready to look at them? Okay. Yeah, that's all right. That's because I have years of practice. I'm going to throw them up there anyway, because you only had to do one of them. There you go. So x squared minus 13x plus 42, 3x squared plus 14x minus 5, 16 and 6 is 22. 8x squared plus 22x plus 12, and x squared minus 6x plus 8. I was worried that I might have got that one wrong. God bless you. So I want to just show you, just because of what Corbin said. I'm so glad he said that. We're going to do one more problem. I just want to remind your brain. That's all right. I'll put it back up in a second. So what if I had something like this? 4x squared plus 7 times 2x cubed plus 3x squared plus 4. What would you do? Yeah, I would make a 3x2 box, because you guys did so well with the box method. If you didn't have the box, you pretty much goobered it up. So 2x cubed. I also like distributing, but you did really well with the box. So 4 times 2 is 8. x to the 5th. 4 times 3 is 12, x to the 4th. 4 times 4 is 16, x squared. 7 times 2 is 14, and there's no x here, so this is just going to be x cubed. 3 times 7 is 21, x squared, and 7 times 4 is 28. So when you look at your diagonals, these can get grouped together, but these cannot. Do you guys see that? So your final answer is 8x to the 5th plus 12x to the 4th plus 14x cubed. And then 21 and 16 is 37x squared plus 28. So kind of couple of things. One, I wanted to remind you of the box method. You're awesome, Corbin. Thank you for that. Number two, remember that when you have terms that jump, notice that we don't have an x term in that first parenthesis or in the second one. So we're missing some power of 1, some variable to the power of 1. Remember when that happens, you're not always going to, that's an example of when you can't always combine the diagonals, right? Because there's a gap. Good with that? Okay, so I just want to show you, I'm going to stop.